It's working. That's perfect. Great. Thank you. What? As a side effect. It's bad. uh, functional programming jokes. This is fun. Okay, cool. So map. Anyway, if you haven't heard of map, don't feel bad. This is like, and even if you don't quite fully get it after we go through today, that's okay. Just like maybe Google it later on or something. I don't know. Whatever. You'll get it. So map. In English, what it does is it takes an array and it returns a brand new array of items that have been changed in some way. So that goes in the immutable thing, right? We're not changing an array anymore. We're like transforming it and creating a brand new array. Cool. So let's look at what this thing and how it works. So this is an example. Remember that imperative doubler function I wrote earlier? This is a functional doubler program. Woo! All right. So we have our array, and we're passing that through. This doubler function takes a single, or it takes 3 arguments, but the first one is element. So that's like the current index in the array. Basically, you can think of all these functions I'm showing you right now. They're just looping. They're basically doing the looping for you. You're just not writing the for loop anymore. So all this is doing, when we do array, it's looping, or it's mapping over that array, and it's going to run whatever you put in here. It's going to take that element and then perform this action on it, and then it returns a brand new array called double array that contains it. That work there. So yes, this is great. So we still have some variables, but it's kind of cheating because like we're just using it to declare these variables here. We could still pass these through directly. But now in our for loop, or this loop that we're doing, are there any variables that we're creating? No, nothing, right? We're able to like hugely reduce the complexity. And now with that for loop too, like we don't have to worry about all that stuff in there. We don't have to declare it. Like this is way more concise. Way more simple. We're just saying like double everything on here. I actually want to show the immutability of this as well too. So I'm gonna go to repl.it. Okay, cool. So I'm gonna show this double array. When we run it, right, it doubles everything in there. But I also want to show array. So this map function totally leaves the original function alone. So when we run this now, we'll see that like the original function still exists and it's totally fine. Whoa. Yeah, maps. I don't use for loops anymore. Like I use maps and reduce functions, which we're gonna get into next exclusively now. I don't know. Like once you get into it, it's like it's easier to write. It's easier to understand. I don't have to like worry about all the extra code. It's a lot faster for me to do it. And as a person reading this code now, you don't have to like sit and read my for loop. Okay, it starts at 0 and it goes to the end, right? It's kind of inferred now. It's just like I don't care how it works. All I know is that it does this thing and then it performs that transformation on that thing. A lot less work I have to like do as a developer. Yeah. So and we wrote a function called doubler, functional programming, right? It's a functional program. Is there any side effects in this function? No, right? Element is internal. It's passed through as an argument, and we're just multiplying it by 2 and returning it. No side effects. So that means if boy, programming with a microphone is hard. Yeah. So yeah, I'm going to run double array 3 times. And does anyone know what double array is going to return? Oh, I see here. I got to do this. And then. What is double array going to have? Or what's the value of double array going to be? Yes, it's the same, right? There's no side effects. Every single time you run this now, it works the same exact way. Let's try it. Yep. So like just like before with our increased functional program, no matter how many times you run it, yeah. Oh, there it goes. Yep. It behaves the same way every single time, no matter what. I don't have to worry about when I ran it, how. It behaves the same way every single time, and it's not going to affect anything else. So maybe I'll get into a little bit more about why that's important. Does anyone know why that's like made a huge resurgence recently? Does anyone know any frameworks or anything that have been like causing excitement around the functional? Yeah? Yeah. Yeah, definitely. Yep. So it's a lot of college curriculums. Yeah. Redux. That's the one. Redux. Anyone ever heard that word before? You don't know what it is? That's fine. Just know about it. That's cool. Yep. Redux. Redux is bringing functional programming to the front end. So now I'm making whole web applications that are completely functional, front and back end, completely functional. So why is that important? Who's made a site with jQuery before? What are some pain points you've had with jQuery? Slow. Traversing the DOM is slow. Yep. The hard part I have with it is managing state. So like I open a modal and I got to keep track of that state with the variable. And then I click a button, I got to keep track of that state. And then I populate some data and I got to track that state. And it all gets stored in global state because I start sharing that with other things, other functions. And then I get confused about what's happening with my function. And that's what happens with these applications where you're sharing massive state and there's tons of stuff. Like Gmail or Google Maps, like there's so much stuff going on the front end, and like if you're managing all the global variables, that's like insane for human beings to be able to figure out. And we're like, there's got to be a better way. And that's when Redux came about. So now what we're doing on the front end is the entire state of our entire front end is being managed in a single immutable object. It's everything, every single button we click, it runs a functional function to update an immutable state that the entire application shares. It's crazy, yes. So I've been teaching React and Redux for years. Yeah, and it's all based on functional programming. Yep. Perfect. So anyway, it's super important. It's not going away anytime soon. Yeah, it's huge and all over the place. Okay, cool. Reduce. So there's a lot of these other methods I'm going to go, or like exist. I'm not going to go over them. There's like for eaches and like filter. There's a bunch of these other ones, but I'm just going to go over map and reduce. So mapping transforms data, returns a brand new array. Reducing is a little bit different. Reducing allows us to do things like take an entire array of data and then change it into returning only a single thing that's left. What? This is the weirdest one. This is the weird one. So for example, this is an example of using reduced to sum up the contents of an array. So reduce method takes two arguments, previous and current. Previous is the previous element in the array. If you don't put anything, it starts at 0. And current is the current element in the array. So what we're doing is we're looping over the array, and it's going to sum up everything. And then this result gets saved into previous for the next value. So if we go through this array, right, it's previous initializes to 0, current is 1, and then we take 0 plus 1, and then that gets saved to the new previous. And then go to the next one, current, which is like 2 plus 1, right? So it adds up everything in the array. So same thing. Does this have any side effects? No. No, right? Because the only two things in there are self-contained. They're just arguments being passed through that thing. This one may take some time to digest. That's fine. Just take it home and sit on it for a little bit. Yeah, we got a question back here? Yes. Yep. It always does. So like you have to pass through two arguments onto this reduce method. And you can optionally set another initializer on it too. Let me show you how that works. Okay. So summarizer. Yep. Previous current. And then I'm just going to run this to show you. Returns 15, so it sums up all the events. You can also pass in an optional second argument that will set the initial previous state on there as well. So what will this return? If we initialize the first previous to 25. Yep, 25. So let's try that, and there it is. Yeah. like if there's an undefined in this array, or what? I guess I'm confused. I think with the new version of ES6, you can set default parameters on there, so there is no previous. But like, that's actually, I wouldn't recommend doing that with this. So what I would actually recommend doing is running like a function before it. So for example, I'd run a filter function on this first to filter out all of the undefines, and then I would then reduce it so I'm guaranteed only with numbers. So like you're chaining together small functions that do very specific things together. I don't know if I hope I answered that. We could talk too. Okay, cool. So if you don't understand reducing, that's totally fine. This took me years and years and years to get this. That's fine. I would recommend is like when you're working on your programming project at home, like Google, like go to MDN and try to figure out what these things are and try to use them in your next projects. So if you see a loop, you're like, oh, like maybe a map would be perfect, right? If you're ever writing for loops, like start like thinking like maybe you could start using these functions in there. All right. Great. Ooh, all right, let's see here. This one, I'm like, I had mixed feelings about whether I put this in here at. I wanted to show like a slightly more robust function. Like actually like a full program that runs something using functional code. This might be a lot. That's fine. Don't freak out if like you don't understand it. That's totally cool. But let's just look at it. Okay, let's see here. Let's make this a little bit bigger. Okay, cool. So this is a functional program, and what it's going to do is basically it's a race function, and it's going to just we have 3 cars that start at the starting line, 1, 1, 1, and they're going to randomly advance every single round, and then it's going to output that to the console log. So let's take a look at what that looks like. Actually, maybe I'll just do this. Okay. Yeah, this is better. Okay. Can everyone see everything okay on here? Got it. Okay, and we run it. And each of these is a separate round, right? So this is the first round, randomly advancing. First car is in the lead, first car is in the lead. Right, okay, cool. So, yeah, I'm not going to spend a lot of time on it. I would recommend, too, if you're interested, like, check out these slides and check out this code. This is, like, I love this. I just think this is really fun. I spent all day on this yesterday, kind of nerding out over it. But anyway, so down here at the bottom, we have a race function. And what are we passing through this race function? An object, yeah. They keep track of what? Yes, exactly. Are there any global variables in this function or in this program? No, there isn't. So the state of this program, how are we passing around the state? How do we know like the current state of this if we don't have global variables anymore? Yes, every function, we have this thing called state that we're passing around. It's basically, there's no variables in here except for declaring functions, which those don't really count. There's no functions. There's no for loops. It's just passing through an object from function to function to manage the current state of the application. And we never mutate that state either. So let's see here. Let's do next step of race. You see we're returning the new state of the application. So we're decreasing this current state by 1. And then, we're making a brand new object. Notices that as well. And then we're running this move cars, which returns a brand new array of positions. So either we advance the position or we just keep it the same for each of those. Notice we're using a map function to loop through all the car's positions. Yeah, I don't know. I'm not going to go too deep into it. I would recommend checking out though if you're curious about it though. Yeah, totally functional. Each step here is very self. This draw function does one thing really well, and that's it. Output just draws the cars out there. Move cars randomly decides whether the car gets to move ahead or not. Right. Each piece is something an engineer could like look at and understand, and I can make changes to it confidently without knowing or without affecting how other functions run in other parts of the code, which is also a huge problem with programming today. Okay. All right. So I want to. I was like, I had mixed feelings. Like this is like cool, but also like I don't want to scare you. So like, don't be too nervous if you're like you're not here yet. That's fine. Okay. Okay. Cool. Recap. I like the recap step because it like reminds people to wake up a little bit. It's like, oh yeah, okay, here we go. So this is the important parts to remember. So functional programming. Functional programming describes what should happen. Note that it's different than declarative programming, like SQL, because we're using functions to describe what we want, as opposed to just saying what we want with SQL. Functional programming: no more variables or assignments to variables. No more changing data. Immutable is like the key word there. No more for or while loops. No side effects in your functions, and no mutating or changing state. Just kind of like immutable. Okay, cool. Let's see here. So, how do you get better at this like crazy weird thing? Anyone know? Practice. Yes, you got to practice. Yeah, that's like the only way to do it. Yeah, it's actually, so I started a GitHub group. I call it FPUGS. It's the Functional Programming User Group. Also, you notice the little kilo pug. And it's got a little lambda for a nose, which it's like, this also is like known as lambda programming, which I'm covering it up. So anyway, that's cute. A friend who drew that up for me. But what we do in this group is basically we do programming problems to share with each other. So we try to solve them functionally, and we share them to the group. Yeah, so something I do a lot is like, if you have heard of like Code Wars or HackerRank or like Project Euler, what I do is I just go to those sites and like try doing those functionally. Can I solve them without variables, without looping, blah, 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 etc. Or if I'm just using a function at home, I'm like, I see a for loop. Like maybe I could use a map or for each or whatever. Like trying, just like slowly trying to integrate more of these concepts into your code base. It will make it better. The less you can have side effects, the less variables, the more like less looping you can do, the better. But if anyone wants to join FPUGS, let me know. I would love to have more functional programmers. But yeah, programming is like the only way to do this. I say this a lot, but like programming is like the only thing where people get like hung up on like practicing. It's like everyone asks me like, what's like the best video to watch? Like a video might help a little bit, but like the only way to get really good at something is to practice it. Like, yeah, Shaquille O'Neal doesn't watch like videos on YouTube to get better, right? Like he practices. Everyone else knows it, but programmer like gets stuck. We get stuck and we got to study. I've never seen anyone who has practiced too much and studied too little. Like it's practice. That's the only way to get better at this. Yeah. Okay. Cool. So this is my question slide. Does anyone have any questions? Let's see. We'll go up here. Yeah.
So given this, I don't understand how you can make a full front-end web application when you can't have any global variables.
Yes.
Bounce around or like modify what you use to see. How do you go about doing that?
Yes. I know. Isn't that crazy? So Redux works. It's just like a regular JavaScript object. And every state is stored in that object. Everything is saved in a single object. I know, it's crazy. It's crazy. And you don't make changes to it. You use like a map function to like make a brand new object with a new state, and then you share that state with your entire application. Oh yeah, it's crazy. Like Redux blew my mind. It's crazy. Yeah. Yes. Like through like an array? Yeah. Yes. No, that's a great question. Let's do it. Let's do it real fast. So we'll run a filter on this, and we'll do like cur, and then we'll do oops, hang on. Great. So this filter function. So for example, if we use the same array, we want to filter out like that undefined, we can just do like return if it is so whatever we put in here, if it's truthy or falsy, like if it's true, it will return. If it's false, it won't. I get those confused, but let's try it out. So we'll do like if this is bang current, so that would be like if it doesn't exist, or if it's falsy, and then some current bang equals undefined. So we're going to filter out everything that isn't undefined. There we go. Yep. Yeah, so like you can use filters to like cut things out. So let's see, actually maybe this would be better if like we just oops. Okay, so we're just going to take a look at this array before we do the summarizer on it. So this is just straight filtered, and we should see that this undefined has been pulled out of it. Yeah. So like you can do things on there just like to. So this is basically saying we're going to filter out everything where this element is not undefined. So everything that's like a regular. Yes. 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 So this is another like these because every one of these methods returns a brand new array. So when I filter this, it returns a brand new array that has the undefineds filtered out of it, and then we pass that new array down to the next one, the reducer, and then it does that work on it. So that's great too. It helps you like you can just like you can insert these like chunks, so like Legos you can like put in your code, and just like if I do this, it will start doing these transformations. I don't have to worry about anything else happening to that code. Excellent question. Yeah. Oh, perfect. Thank you. Eddie Wood. Yeah?
So you were saying that there are languages that are
Yes. Yes. Oh, I totally forgot to cover that. Yes. Does anyone know any functional programming languages? We heard OCaml, Haskell. What's that? Elixir. Yep. Eclipse. Is that what I heard? Oh, Lisp. Yes, the original. OG. Yep. Closure. Yep. Yep. Scala. Yep. There's F sharp for functional. And then, does anyone know for JavaScript? There's some JavaScript functional languages too. One called Elm. Elm is like the big one right now. Actually, it's on my to-do list for this year to learn Elm, but look into it. It's totally awesome. It transpiles down to JavaScript, so you can write functional code now in the browser, which is cool. And Phoenix, if you're used to like Express servers, Phoenix is great for like node servers, but they're functional. Yep. Yes. Any others? There's a lot. And JavaScript supports these functional, like JavaScript supports imperative, object-oriented, and functional programming paradigms. So you can just I kind of mix and match them in there too, and Python does as well. Cool. All right, that's it. Let's see here. So thank you so much. Appreciate it. This is great. And if you were following along too, here's some additional resources for you. I have some stuff on here too, like just like additional stuff, link to FPUGS, and some great resources for like just getting started. There's also links to each of those JavaScript methods I didn't cover today too as well. Yeah, anyway, I'm Joe Karlsson. Thank you so much for coming. Thank you.